All right, if everyone can turn to the camera and wave. My name is Sean Marsh, and I'm here to talk to you guys today about near-Earth objects. According to NASA, a comet or an asteroid struck near the Yucatan Peninsula in Mexico some 65 million years ago. And it caused a massive extinction of more than 75% of the Earth's living organisms, including the dinosaurs. In 1908 and again in 2013, an asteroid detonated above the ground in Russia. The 2013 event occurred above the city of Chelyabinsk with the force of 500,000 tons of TNT. And it caused massive building damage, some injuries, but amazingly there was no human loss of life. The 1908 event occurred above Tunguska with a force of 3 to 15 million tons of TNT. And it leveled some 400 square miles of forest. In order to prevent an extreme event, mankind needs to identify objects that have the potential to enter Earth's atmosphere. And they also need to come up with a solution to prevent these objects from reaching Earth. After learning about near-Earth objects in astronomy, I researched the possibility of one of these objects impacting Earth. Near-Earth objects, or NEOs, are asteroids or comets that approach Earth closely. And what I learned was that the world as a whole was working together to address this growing concern. Not only do asteroids and comets have the potential to end all life on Earth, they also may be the reason for life on Earth. Asteroids and comets that impacted the Earth after the heavy bombardment are thought to have brought most of the water and carbon-based molecules that are essential for life. In 1995, a group from the UN got together to discuss how humans could address the potential for catastrophic events caused by a near-Earth object impacting our planet. The outcome of this conference laid the groundwork for the world to work together to help identify threats to Earth. And they also discussed the potential measures that they could use to divert these objects. The key to being able to deflect an object is time. The sooner an object can be detected, the more time scientists have to devise a plan to intervene. One of these options is to detonate a nuclear device near the surface of the object. Now, this explosion will change the course of the object by only a small amount. So the further away the object is, the more likely the chance for success. Another option is to blast the surface with radiation. And this will cause the surface to vaporize, and it will impart a momentum change that will alter the object's course. Another benefit of researching near-Earth objects is the potential for them to be used in future space travel. These objects can be used to construct structures or used as outposts in the far reaches of our solar system. Comets, which are mostly ice, are a great source of hydrogen and oxygen, which can be used as rocket fuel for deep space exploration. In conclusion, a two-pronged approach is necessary to save the planet from a catastrophic impact: early detection and defensive measures. NASA has already detected all 90% of objects at least 1 kilometer or larger, and they are working to discover 90% of all objects larger than 140 meters. These agencies have also developed measures to deflect an object in the event it were to pose a threat to Earth. And although our solar system is a dangerous place, the key to unlocking these dangers is study and creative thinking. It seems frightening to think that the world could end so abruptly as a result of an impact. However, you are much more likely to die in an auto accident. And as space exploration grows, the likelihood of an impact lessens. If you're interested in learning more about near-Earth objects, I would suggest the NASA's Center for Near-Earth Object Studies at cneos.jpl.nasa.gov. Thank you, and I hope the information that I've shared today gives you some insight into the future of our world.